Good afternoon. The topic for today is Zener Diode. Myself, Dr. Indu Nayarvi, belonging to the Department of Artificial Intelligence and Data Science, SNS College of Technology. So we have on the previous video, we have already discussed about diode, and that diode conducts only in one direction. Today we are going to see about Zener Diode. So how it is designed and the application of Zener Diode. So what is a Zener diode? A Zener diode is a heavily doped silicon PN junction diode designed to operate reliably in the reverse breakdown, providing a stable constant reference voltage, typically 2.4 volts to 200 volts in circuit. Unlike the regular diodes, they conduct current in reverse when the voltage reaches a Zener voltage, acting as crucial component for voltage regulation, every over voltage protection and signal clipping. Construction of Zener diode. A Zener diode is similar to PN junction diode but heavily doped on both sides. This results in a very narrow depletion region, precisely low breakdown, sharp and controlled reverse breakdown. So the symbol is the same as ordinary diode except for the cathode, in which the straight line is bent at both the ends. Working principle. So key characteristics and working principle. So the most important thing is the reverse bias or reverse operation. So in the forward bias, it is going to act just as a normal diode. Whereas the reverse operation, xenodiodes are designed to be operated in reverse bias, cathode positive relative to anode. Zener breakdown. Once the reverse voltage hits a specific Vz, the depletion region becomes very thin, allowing electrons to tunnel through, allowing current to flow. And there is other effect called as the avalanche effect. For voltage generally above 5.5 to 6 volts, the breakdown occurs due to collision-driven charge carrier multiplication, or otherwise known as the avalanche effect, which has a positive temperature coefficient, unlike the Zener effect's -1. Voltage regulation. Because they maintain a nearly constant voltage Vz across their terminals, even with varying current, they are used to maintain stable voltages. And an important point to note is that the reverse current flow is very small. It is in the order of microamps or nanoamps. So Zener diode high current region, reverse leakage region, Zener breakdown region, and Zener diode. So Zener diode is a heavily doped silicon PN junction designed to reliably operate in reverse bias once a specific Zener voltage is reached. Unlike standard diodes that break down, Zener diodes safely maintain a stable constant voltage across them, making them essential for voltage regulation, surge protection, and reference voltage generation. Zener breakdown. Zener breakdown occurs in heavily doped PN junction, which results in very thin depletion region, which will be less than 10 nanometer. When a reverse bias voltage is applied, it creates an extremely strong electric field around 3 into 10 power 7 volts per meter across this narrow region. This intense field is sufficient to directly pull electrons from the valence band of the p side into the conduction band of the n side, a process known as quantum tunneling. This generates a large number of free charge carriers, leading to sharp increase in reverse current. Avalanche breakdown. Avalanche breakdown occurs in lightly or moderately doped PN junction, which have a wider depletion region. Under a high reverse bias, minority charge carriers gain significant kinetic energy while crossing this region. These high-energy carriers collide with atoms in the crystal lattice, imparting enough energy to break covalent bonds and generate new electron-hole pairs. These newly created carriers are also accelerated and cause further collision, creating even more carriers. This cumulative process, known as carrier multiplication or avalanche effect, results in a large reverse current. So Zener diode as voltage regulator. So VZ or Zener voltage, the regulated breakdown voltage. IZ Zener current, the current flowing through the diode. Data sheet list IZ minimum for breakdown to occur and IZ max to prevent damage. Power rating PD, maximum power dissipation, calculated as VZ into IZ. Typical applications. Voltage regulation, providing a stable voltage for sensitive component. Example, voltage regulation circuit, Zener diode are reverse biased across the load. Over voltage protection, connected in parallel, they clip voltage spikes and protect components from transients. Example, in over voltage protection circuit, the Zener diode is connected in parallel with the component. Voltage reference, used in circuit requiring a precise reference signal. Clipping waveform shaping, clipping parts of signal waveform. So we come to the end of this section. Thank you.